everyone. Welcome. It's time once again for Catalog and Cocktails. It's your honest, no BS, non salesy conversation about enterprise data management with tasty beverages in hand. I'm Tim Gasper, longtime data nerd, product guy at Data.World, joined by Juan Cicada. Hey, Juan.
Tim, how are you doing? It is Wednesday, middle of the week, towards the end of your day. We are live today, and I'm super excited to have Hala Nelson, who's a professor of mathematics, author of the O'Reilly book, Essential Math for AI, and who's currently writing her second book, AI-Powered Digital Twins. Somebody, again, I love it when we get to meet on the road at conferences, and we finally get to have you on the podcast. Hala, how are you doing?
I'm good. How are you all?
Well, excited to have this conversation, which I know we can go so many different ways. So excited about that. But hey, let's kick it off. So what are we drinking and what are we toasting for today?
So I'm having my morning coffee. I've been having it all day long. And then Juan just convinced me offline to pour something else in it. And I'm not going to say what I put in there. Think Irish sort of.
That does it. I mean, actually, just good. Some make it an Irish coffee, right? Just I love making some coffee cocktails. Tim, what are you drinking today?
I'm not an Irish coffee, although I haven't had one of those in a long time. I should try one again. I actually didn't know what to make today, and so I asked ChatGPT, "Hey, here's all the ingredients that I have." Lately, I've been using the voice dictation because you can just tell it all sorts of stuff, and it told me to make a rusty cherry. So it's kind of like a rusty nail, but it's got some cherry hearing in it. It's pretty solid. So, cheers.
Love that.
And I do the other ways. Like I give it my ingredients to help me come up with a name. So I have some tea infused gin that a friend of mine gave, and I had some blackberries in my house. I usually don't have blackberries, but that was interesting.
Like
blackberries? Fresh blackberries. And then by coincidence, I had blackberry lemonade, sparkling water from Waterloo. So,
wow.
So all this turned into what I'm now calling a node in bloom.
I love it.
And I asked, I asked
like a graph node.
Exactly. So here's what happened. So I gave all these ingredients and they come up with names, and I came up with a bunch of boring names. And then I said, hey, give me some data, put a data twist name. And it actually separated. It said, here's some data flavors, analytics inspired, and then graph lovers, and then just for fun. And so I chose the Node and Bloom. So the other one could have been the ontologen, which is actually like that.
That's too corny. You can't do that one.
All right. What are we toasting for? What do you want to toast for? Hala.
Oh, let's see. I will toast for the almost end of the semester. At this time of the year, academic professors and students are afraid. So we're almost there. One more month, and yeah, I'm toasting for strength.
Strength and just you're almost
energy.
There we go. Cheers. All right, because we're to be talking a lot about digital twins, and we'll get that in a second. A warm-up question is: if you had a digital twin of yourself, what's basically you're cloning yourself? What's one thing you'd make it do so you don't have to do it?
Let's see. I would have it do the active teaching part of my profession. I would have the digital twin give a lecture, and I'd just be personally talking to every single student the whole time, and just toasting with them and going throughout their personal and career stuff, and just connecting with them at a better level. And it's kind of happening now, slowly in terms of teaching.
Now that I hear you, I would actually, in a way, to scale that out, wouldn't you want to do it the other way around, that your digital twin is able to talk to all your students, so you can therefore scale that out? Because otherwise you're still kind of in parallel. I don't know.
The thing is, I do like the human interaction. I mean, I do love my students. I want me to connect with them and not the digital twin.
That's true. I like that. Tim, how about you?
Well, the joking answer I was talking about when I said that ChatGPT made the cocktail recipe for me was that I could just have it do all my thinking for me, which maybe it's doing a little too much of these days. But serious answer is, doing product, I have to meet with a lot of customers, and I have to gather requirements and talk about what they want to do. And I rarely have time afterwards to actually write everything down and organize it all. So I wish that, my digital twin was just hanging out with me and just saying like, hey, I already wrote the requirements for that. And here you go. Does this look good? And, I feel like we're pretty close to that. I bet I could get close to that today.
Yeah, I think for me it would be, well, when I was thinking about something in the kitchen, like doing my dishes, or actually this is for you, Tim, is like chop chop my onions and my
Oh my
carrots.
gosh.
Vegetables, chopping vegetables. I think that's a great one in the
Well,
cooking.
but the joke
Juan
between
and I have a big debate about this.
but I enjoy it. I enjoy chopping. It's just, for me, it's satisfactory. Like, I don't want to give that up. So
And my opinion is that if the robot can chop the vegetables for you, let the robot chop the vegetables.
They will look really, really nice. Professional.
all right, let's kick this off. All right, hold on. Honest, no BS. What is a digital twin? Let's start with that.
Well, you guys started with like the heart of it. You started with with human digital twins, which is insane. The way I see it is through at different levels. There's like the inanimate object digital twin, like a manufacturing part, a part of your car engine, the wing of a plane, a building, the built environment. So there's all the digital twins of these objects and things that go in our. Then there's a second level, in my opinion, and each of these levels has its own set of difficulties in terms of modeling and how to bring it to life. The other level, in my opinion, would be more on the processes level. If, for example, you're in an organization and you want to model the processes that happen in it, to twin the processes in order to streamline some of them, make some interaction with them easier. And the third level, which is the human digital twin, and then that will include reasoning and lots of twinning aspects of our humanity and intelligence that you wouldn't find in the other two levels. So I would define a digital twin as the digital or virtual or cloning of either an object, a process, a human, and then our ability, and it's not a digital clone, it's also our ability. We have the ability to interact with it and to modify. If you modify the digital twin, you want the physical twin to react in how you. So there's this back and forth synchrony between the digital object and the physical twin, and so that's how I would define it. I would say there's a point left in my mind, but yes, let's leave the definition at that for now, and we can expand from there.
No, that makes a lot of sense. So we jumped straight to the human piece, and probably that's because we're playing with a lot of AI and agents and things like that right now. But like, for example, if we wanted to use the chopping the vegetables kind of analogy, like the simplest version of a digital twin might be the digital twin of your fridge, right? What are all the ingredients that you have in the fridge? If you have that replicated, cloned in a digital fashion, well, now all of a sudden you can do all sorts of things with that. You could do better inventory management and things like that.
Correct.
So that could be an example of a very simple version of a digital twin.
Exactly. And also I want to add that we have been digitally twinning since the dawn of the digital age. It's just as we gain more compute and as we gain more as our data engineering and computational power have expanded and matured, then we're able to twin more. And now that we have AI, then we can bring these digital twins to life. For example, Google Earth is a digital twin, except that it was static, and now with like continuous stream of information, it can be brought to life. It could be, your digital twin could be the dashboard that you look at in for an organization, like what's coming. That is a digital twin. So digital twin does not have to be a three-dimensional model of whatever you have it can be just a dashboard that you're looking at, and you're streamlining all this information and what you do with it. So it's such a broad definition, and now we have the ability uh, to to twin at a much larger scale than we ever were able before, and to include AI in it as well, which we weren't able before. And AI brings it to life, and to also send information back and forth between the digital twin and the physical twin. So that has in our new way of looking at digital twins is in a way all encompassing, all integrated, and at a level and at scales that we were never able to do before, because of the data engineering maturity and because of the AI and computational power that we have now.
But I would argue that you said something that it's the back and forth, right? That kind of that symphony. And I think that's what makes it between the digital and that physical thing. Because
Yeah.
otherwise, if we just say like even dashboards are digital twins and everything's a digital twin, then we just kind of lost the
Exactly.
definition of this, right? So
Exactly.
and I think it's in a way this is just kind of what simulation on steroids or something, because we've been doing simulations of things for, again, as you're saying,
Forever.
forever, right? This isn't new.
Yes. Yes.
So it's like in a way, I'm like you have the physical world and then you have your virtual, your digital world, and you want to be able to kind of simulate or try these things that you can do in a safe space, and then when you learn, you should be able to kind of bring that back and then see how it actually operates or it performs in the real world. And technically, in a way, it's kind of like we do in science, right? Here's where I do my experiments in the control scenario, and then, oh, that looks well, but we bring it back to the real world, and it better work because that worked in the experiment. And if it doesn't work, then we probably know that we're not really, I like this term, digitally twinning enough, right? We're kind of missing some
Correct.
of
Correct. It's exactly how you describe. And the fact that you're going back and forth from the physical object to the digital twin, you're ideally streamlining with sensors, depends what you're twinning, sensors, measurements, video, whatever it is. What we have different now that we didn't have before is we're able to process all that data in real time and trigger alerts and trigger these alerts and decisions in our language, as opposed to someone looking, say, at the dashboard, what do I make with this number, it's very different kind of interaction with the twin than before. It's it also opens up the road to a lot of vulnerabilities that we have to be very careful about, because because our physical world is now a sensed world. Even it's a sensed at a scale that's never been before. And then you can cause a lot of harm when you using the digital twin. So basically, if anybody has access to your digital twin, they can do stuff that they were never able to do with the physical environment. So it's amazing that we can use the digital twin to monitor, to enhance development, product design, whatever it is that you care for, streamline processes, but also opens the road of a lot of interference. It's a blending of the physical and digital realities that we have to design carefully, and it has a ton of opportunity, but also we have to design carefully. And that's why I always have two imperatives in my book. The new book, it's going to be the AI native approach, in the sense that we have a technology that we can deploy at the scale that we weren't able to do before. And as I said, understand and do decisions with data from all kinds of modalities, and trigger decisions, write reports, whatever you want. But and even suggest new experiments, new simulations, new trials, new tests, whatever it is, that you're doing. But at the same time, it's also another imperative to introduce the standard of care. It's in the engineering process. So it's and these two cannot be divorced from each other because of the digital twins. They're blending physical and digital realities, and we have to do that carefully.
Yeah, no, that makes a lot of sense. And this, the opportunity to do harm and the need for a standard of care, it does create a new surface area here. One thing that's interesting to me is that, as you mentioned, the idea of a digital twin, conceptually has been around since the beginning of the digital age. And, you can go back all the way to the first computers and things like that. And even before that, depending on how you want to think about the digital age, right? But obviously, a little more recently, I think we've been hearing people mention that phrase more often. And I'm having
Mhm.
trouble remembering exactly when I started hearing it, but I remember back in the Hadoop days, back in like 11, 2010, I remember folks being like, oh, we should create a digital twin and we can use now because of big data technology, we can do this. So I'm curious, when do you think kind of we started talking more about this as like a
Mhm.
phrase and as a theme? And are there certain use cases in industries where you're seeing digital twins be more impactful? Like back then, I
Mhm.
remember talking about it a lot in the context of like predictive and preventative maintenance and things
Mhm.
like that. Curious
Correct.
about
Yes.
some of the use cases.
Yeah, so I would love to dig in the history of it. When I was writing my AI book, I dug in the history a little. My Let me say my unresearched answer, because I can tell you when I got in this, and I realized that this needs to be done and written. But I would say it really got born in the as a term. If I have to guess, and this is my unresearched guess, would be in the manufacturing parts, and in the when people were doing also AutoCAD for buildings and for the architecture. So people have always had that. The only thing is they were not alive, and they were not always. It's a physical. It's a virtual manifestation, like a 3D object, but it's not taking a streamline of data. It's not alive. It's a static model of the part, and these are super helpful. And people used to have them on blueprints before, and then they became the digital. The reason in the age of big data it came more in popularity is that they're very computationally expensive. They have a lot of they you have to have a replica of your physical object or process. You have to have the a lot of points. I mean, Juan does simulations, and these are very expensive computationally, and to actually have 3D manifestations. I mean, I remember the first time I ever downloaded CAD on my laptop. I just downloaded it stupidly. I started working, it crashed. It never survived after. So I didn't know, I didn't appreciate the amount of computation that goes in this. And then that was before the cloud. And then you have the incredible chips now that we have. There are chips that NVIDIA makes that's special for digital twins. We have the AI, and we have distributed computing. So all of this brought the dream of twinning our even interconnected system. Like you can twin, I don't know, the whole human interaction network, whatever it is. Like our dreams kind of came back to life, and now that we can integrate it with AI, then that really revived the whole community, and now there's a community that's growing around it. And as I said, there are chips that are, I think NVIDIA's what is called omniverse, something like that.
Mhm.
It's very, very powerful, and can handle and the computations that go in digital twins is also, from a modeling perspective, is multi-scale. So to have these models that have the minuscule all the way to the macro, and to put them all in one computation, that's also been a challenge that now we don't have to have this challenge anymore. So a lot of work is going in that direction, and a lot of excitement.
So then let's dive into what you mean by AI here, because you're saying there's AI powered digital twins. That implies that there are digital twins that are not powered by AI. So
Mhm.
what is this differentiator, and specifically what do you mean by AI, and how
Yeah,
it's implementing
it
digital?
if we step just one step backward, is what is it that you're twinning? Are you twinning a manufacturing part, or are you twinning a business process, or are you twinning a human? I think if you're twinning a human, it's kind of somehow clear, because then there's all the aspects of speech, and no, and you have to build on the data of how that person thinks, what their like say written works are, whatever it is that you're twinning. You want to bring a person back to life,
So,
start
so,
asking
so
questions.
hold on this aspect. So, would you consider, when you're starting to see all these examples of, like, I literally have my digital clone of myself, like that? That literally, we're talking about the digital twin. Now, you see this in, like Reid Hoffman
Yeah.
does it all the time. Like, you can chat with Reid Hoffman, or Reid Hoffman, the person,
Yes.
right, is chatting
Yeah.
with Reid Hoffman, the digital twin, and going back and forth. So that's the human digital twin, and it's possible because of all these large language models and generative AI.
Exactly. And say you're doing it. So in that sense, it's a bit clear, because you just like put a person's work, a person's image, a person's I don't know, data about how they interacted with the world around them. If you have that data, and then put it in models, and then they'll bring it back to life. But for example, you're twinning an organizational process. Then of course you have to do AI, because first you have to define the process. If say you want to reimburse a person $300 in your massive organization, and then who is that person? Is there an employee? Where is the money coming from? What did they do? And which departments contribute? Which accounts? So there's a lot. Say this process is as simple as reimbursement, can involve multi departments. Say it involve finance, the person's department, the purpose of the money. So get a multi approvals, a lot of things that in large complex organizations normal staff cannot navigate, or they need a lot of training to navigate. They still make mistakes. You still could get fired, could get reprimanded, you get frustrated. So there's a lot of say you have such a process that it seems simple, but there's a lot that goes on in it. So of course, AI, to twin that process, you have to start, in my opinion, and we've done it this way. In my organization, you have to start with like a graph of what goes into this process, how does it proceed, and then what data comes into it, like what are the policies, what's compliance, what regulations, and what's the levels of authorizations, etc. And then you kind of, how do you streamline it? Then you throw like a language model on top of it, on top of that guided process, and then you have a twin process that the staff who's trying to reimburse a person will navigate easily as they communicate with the AI, because it's a twinned process now in your organization. You can have thousands of these processes that are twinned, which we didn't before AI. We could not have. We could like what did we do before AI for organizational processes? We would just like document them, and then we end up with like so much papers and so many conflicting policies. Like with AI, you can like, are these policies in conflict or not, or at least like you can say, well, this way you go about it would be compliant with this policy but not with that policy. So now we can navigate, and we can twin processes in ways that we couldn't do before because of AI. So this one we say AI powered. AI makes a huge difference. Even if you're doing an object manufacturing part, say you are doing maintenance on a ship in the shipyard, you have the virtual replica of your parts in the ship. But if you have like data being streamlined to you of, hey, this is going bad, now you have trigger alerts. So before we could not, with the AI always brings it to life, brings something that's static. You can have the documents that guide processes. These are static. You can bring them to life by interacting with them, by modeling them correctly, and then interacting with them. So this is where the AI step comes in, which we did not have the option before.
So hold on, this is a lot to unpack here. And I'm taking some notes here, and I want to repeat this back. So you said when it's about, first of all, we go back. You talk about the objects, the process, the humans, right? And we're focusing on the process. So to really have this digital twin of the process, well, you got to define this process, understand that. And if you look at it in a before AI world, like all these processes are pretty static. They're in documents, and you don't know how they're
Yeah.
connected and what conflicts they have. So now kind of the AI powered digital twin for the process is like, oh, now we can actually start turning these things into computational artifacts, right? And let's represent it as a
Thank you.
graph, understand what are the inputs and what are the outputs, and the output of one process is the input from another process that's up.
Correct.
And now you can have this, and actually you can then find the conflicts, right? Hey, this is where this is agreement, or let's figure out. By the way, these processes that we actually have defined, they are in conflict with each other, or here are these processes which are too complicated that we can actually kind of simplify. And
Yes.
once you actually start defining these processes, first of all, you could use AI to help you define or put together these processes, and then you
Yes.
can actually use AI and put in LLMs on top of it to be able to go interact and ask questions, saying, "Hey,
Correct.
if I'm trying to go do this, what are the steps I should go do to be able to go deal with it?"
Exactly. Exactly. And this is That's exactly what I'm trying to say. And then you can uncover inefficiencies, you can uncover duplication of effort, you can uncover new ways to go about doing things that you didn't think about before as an organization. So there's a lot there's a lot of potential that and ability that we didn't have before.
Yeah, I didn't originally think of it from this way, but as we've gone through this, and as you've talked through this, Hala, today, like, a lot of people have this dream, this idea that they're like, oh, AI, like when we like fully realize what AI is going to do for us, it could run our business for us, right? Or at least part of the business, right? And they have this dream about it. And I think that the overly simplistic way of thinking of it is like, well, as LLMs get smarter and stuff like that, right? But like, if you don't actually have the eyes and the ears and the senses of what is happening with your business, how is AI supposed to run your business? So it sounds like to me that if you really want to make that dream come true, then you have to have a really effective digital twin of that business process if you want AI to effectively help you monitor it, troubleshoot it,
So
simulate it, and perhaps even run it.
I agree, and the more complex your organization is, if you have one department and three people, every process is defined, everybody's job function is clear, and they overlap a little, and that's fine. But in bigger and more complex organizations, a lot of that stuff is neither documented. I mean, if you actually have it documented somewhere, and even though it's static, that's actually that's unusual. That's, oh wow, you actually documented it. You have somewhere digital to start from, but a lot of this knowledge sometimes is in someone's head, and they leave on also they different department heads give different answers because it's neither documented nor updated. So you kind of start from there, and you also you don't try to twin everything you have at the same time. That's actually impossible to do, and overwhelming. It takes a lot of resources. You kind of start with what is your pain points, and why is it always failing? And then you kind of sit and think about it exactly in the same way you just described them. And once you have that, then you start building the knowledge base for the AI, and also you have to have the security measures in place, like the access, who has the authority to get this answer as opposed to some other answer. So there's a lot that goes in it. It's not like, okay, I wish AI will be able to run my business for me, but before that, all of this has to happen. And a lot of us are nowhere near that. But you have to start somewhere. We cannot say, oh, our data is not in place and we can't do it. Yeah, no, you can. You just have to start somewhere. Start with your pain points. Start with the people doing this stuff. What part of your workflow you would like to automate? What part you want to twin? And then you sit there and involve them. And then you can do that at a big scale, because you have people everywhere who would like to automate and twin some parts of their workflows. And this is kind of tried, and we're kind of now trying it more in different organizations. So it's not theoretical what I'm saying.
So I want to hold this, because this is another thing about like, how do we start? And you're going into that. I want to go back to the whole process. I have a comment in that, because I want to continue then on the AI powered on the objects part thing. But on this process part, this is interesting. I'm personally very fascinated and interested in this area, because this is a conversation I have with a lot of the very strategic kind of forward thinking leaders are the ones who are seeing, oh, I want to start connecting and building this brain, the context brain of my organization. So, because I mean, by the way, the LLMs don't have that context. That's what I'm building here, and kind of this is where all these knowledge graphs come in and so forth. But the thing that I'm actually personally working on right now in our research lab is I want to be able to extract all this tacit knowledge that's in people's heads and start connecting it with more of the existing entities, objects we have in our organization, specifically the processes too. So it's not only is like, what do we mean by this object, but like, actually tell me how you do your job, because there's a process, are these things which involve these objects. And then we all, now what it's interesting, one of the things I'm finding that's going to be interesting is the incentives to get people to actually share that knowledge that's in their heads.
Yes.
Because, hey, knowledge is power. They be afraid about this stuff. So anyways,
I couldn't agree more.
Right there.
Oh, I couldn't agree more. And you just opened our next point, is the human-centered way of doing this. They have to be at the center. The people who are mostly affected, you start with them. You like in your department, you want who has a pain point, and do you how would you like it to be streamlined? And they will give you their ideas. It's their work. They've thought about it way more than we ever did, and this is how we did it. And so you start with them and their own workflows, and you don't start with yourself and your technology. That's the wrong starting point. No one cares about your technology. You just start with them and their workflows, and they know way more than you do, and their pain point. If they're totally fine with the way things are working for them, then you go to someone else who wants to automate that process. And eventually it propagates a culture of like, oh, look what I've done here. They start participating and building. So the human aspect, the culture, the organizational culture aspect of it, it doesn't come in one day. It is a process also of having them at the center, and starting with them and their pain points, and you just sit with them as enabling, showing what the technology is able to do, but with their input. They're the ones who will tell you if this process is eventually, if this automated machine process is giving the right answers. I don't know if they're giving the right. It's not my work, it's their work. So that's why they have to be at the center of the whole process when you're twinning processes in an organization.
All right. So then going back to the whole AI powered digital twin, we talked about the human, we talked about the process. What does it mean then for the object?
for the parts or for the building. And to me, that's very important, especially in terms of security, safety, maintenance, competitive advantage. Let's start with security and safety because I actually care a lot about that. Think about our critical infrastructure. What's a critical infrastructure? It would be energy, it would be water, it would be transportation, communication systems, defense, nuclear reactors. So basically, this is what for our financial system. So all of this is our critical infrastructure. Say in the water systems. So if you have any part of that that's being automated now, like connected, say it's connected to some sort of network, then you have to uh, to digitally to digitally twin that, in the sense that it's very vulnerable. It's been attacked. It's been cyber attacked. It's so by having a streamline of data coming from our buildings, our water facilities, our electric grid. If you have that streamline of data, you with AI, you can see things that you weren't able to see before with only human inspection or classical monitoring. AI is able to sift through way more events, able to trigger unusual activity, generate reports. The AI agents can connect with the right person. So there's a lot there that like twinning buildings that are anything that is connected to a certain network. You have to be thinking in terms of twinning it now as well, because before the we would build them, we would connect them, we would not think about security because we wouldn't think that about why are we more vulnerable now in the age of AI? Because the people don't have to have computer science expertise or any sophisticated expertise to launch an attack or to build an agent that launches an attack at scale that targets things that we rely on every day. The AI age has removed the barrier of access to both good actors and bad actors. So good actors are going to build and do good stuff, and but bad actors are now can launch attacks without any sophisticated knowledge, right? They just need a little bit of AI writing their code for the, and then they can attack at a scale that we couldn't have before. So in that sense, a digital twin that's very well monitored, and so basically the attacks can happen with AI, and the protection can also happen with AI. So that's how I see it. Uh, Even if you don't think about vulnerabilities and security, safety, etc., you can simulate now, and that brings me back to my training in applied mathematics and simulation. As I said, I don't know if I said that online or offline, but the scale, a part has multi-scale in terms of its modeling. Like, for example, on some parts of the part can have the mesh size has to be minuscule to capture the dynamics correctly, and then other parts they don't have to be. So modeling mathematically and doing computation with at such varied scales, that's also a challenge. And now with AI age, it doesn't have to be a challenge. There are papers where the AI can learn, for example, the mesh size in the digital twin of the object depends on where you are geometrically in that object. So there's a lot of potential. Again, there are a lot of hurdles that were hurdles before, and they're not hurdles anymore. Whether you're in one part, or whether you're monitoring the part itself and sending data, or whether you are in buildings critical infrastructure and trying to defend it and replicate it and find efficiencies, whatever. So again, I always say a lot of ideas in like 2 minutes. This is how my brain works.
No,
Our,
I think that's awesome.
our takeaway session is that our takeaway section is going to be very
We're
interesting.
probably taking too many notes as it's happening. But so you came back to this a minute ago. This there's AI and digital twins are going to help us to interact with more bad actors and more good actors than ever before, because of scale, because of accessibility, because of automation. And earlier in this session, you mentioned about we need to establish a new standard of care. And so I'm curious, could you go into a little bit more about like what do you mean by like a new standard of care for engineering?
Exactly. I actually was hoping you would ask me that question. So right before I came online, I actually Googled. I asked AI, just tell me what a standard of care is in engineering. And once I read the response on here with you guys, you would immediately connect it to a standard of care of AI-powered digital twins, and even a standard of care of any AI environment, any AI agent. So if you read the standard of care, so a standard of care in engineering and architecture, that's always been there. That's just how it is, right? How they operate. Even in the even in the emergency response, for example, departments, like for example the fire department, they have a standard of care that they operate on. So anything that we have to build or rely on that affects our safety and our operations plus safety, it cannot be just built and deployed like the way it is now with AI. But this is and then because AI and AI-powered digital ways are blending, are affecting our physical realities, not only our data. AI does not only affect our data, or our digital existence. It affects our physical existence as well and our safety. So there's an imperative there that we don't just go ahead and build without implement a standard of care. So I'm going to read the standard of care for you that I got from the internet. The standard of care for architecture, construction, and engineering have basically the same premise, using knowledge, experience, and expertise to complete a project with a degree of care that meets specifications and prevent harm due to negligence that would result in injurious or financially damaging events. So the engineers are responsible for structures design, cost, and soils report, for example, and must account for any additional loads put on the building, such as equipment, storage for load points. Every aspect of construction and its design should be inspected and documented. And think of the AI models and think of what we deploy. Think of the whole AI supply chain when I'm reading this. Every aspect of the construction and its design should be inspected and documented with the responsible party signing off to verify completion and the proper specifications. So if you apply such a definition of standard of care in engineering to how we build AI at all its levels, from the training data to the models to what it's integrated with, to the hardware as well, and secure that and have you build it according to standards, specified standards, then you are thinking of safety as part of the design, safety and security as part of. So that's the other imperative that we are pushing for. And yeah,
That's awesome. My brain is spinning right now. I know
Yeah,
yours is
I'm
one
going to
as
make a quick.
well.
I'm going to make a quick comment, and I'll throw it to
Yeah.
you, Tim. Is everything you just said? So two things. One is, um, before we got online, right? We were talking all about you're a mathematician, I'm a computer scientist. We have our imposter syndrome, all that stuff. But I'm like, you know what? You look at engineers, right? All engineers, they have to get up their professional certification. I mean,
Exactly.
my wife's a behavior analyst, and she has to get her BCBA, and she has to renew it every couple of years, and she has to get CRU or CERs or whatever it is, right? She has to get all these credits and do this all the time.
Exactly.
And engineers, everybody has to go do this, and they have to go to conferences. They have to educate.
Yes.
Why us computer scientists and other people don't? Why don't we have to go do this, right? And the way,
Because we did not, before we were only existing in a digital reality that we never thought it would blend and affect anything in our physical reality. And now it's just the stakes were not high. And now the stakes are really high. They are everything now.
so
Uh,
this, so
so
this is an excellent point, and I think this is. I wonder how much that's into like coming to an inflection point that even when you, as if you study computer science, which is I did, like if my colleagues who are starting engineering, like they had to go graduate and they had to go get their professional degrees in architecture to do this. So I wonder what's happening, people doing computer science and data science and all this type of stuff. That's one thing. Now the other, I hear everything you have about standards of care about engineering. I'm like, this sounds like data governance.
yes,
Governance, AI
part
governance.
of it, part of it is governance for sure. Part is governance, part is cyber security, and cyber not in the traditional sense, cyber in the sense that AI pulls from all directions and data from pulls and integrates data from all kinds of sources. So you have to rethink your cyber. Also physical safety as well. I mean, if you're twinning physical environments and interacting with them, there's also the physical safety aspect of it. So there's a lot of layers, and even the AI itself. For example, when DeepSeek came into the market and crashed the markets, some people started using it. And did they download every file? Did they read every line of code to make sure there's no unsafe code in there? I mean, this is like when we say standard of care, it has to go through the whole supply chain of your AI, of your digital twin models, and of the physical environments that or processes that you're twinning. So there has to be a holistic safety and security standards and specifications that you are thinking of. It cannot be just like, oh yeah, let's download this, let's patch this, let's use this. And this is how we've been operating. We're like, oh, this software does this for me, and I need it. Yeah, let's grab it, let's do it. However, if you're integrating, if you're using this for anything in your operations, if you're basing decisions on your models and your twins, and then it's not safe anymore. And even now it's not safe. We're being attacked. I think we are being attacked in our critical infrastructure more than we would like to. I mean, so there's a lot there. It's because we did not build with a standard of care in our head, and we did not think that would come a day where both our physical and digital environments are blending. But
Yeah.
now they have blended, they are blending without us having set that in place. So
Yeah.
that's where this imperative is coming from.
Yeah, no, this connects in my mind also to responsible AI, right? And obviously that affects a lot of different pieces. Governance is part of it, but cybersecurity, overall sort of organizational understanding, right? In the same way that everybody needs to learn that you can get phishing attacks via text message saying, hey, if the CEO is asking you for a gift card for $300, maybe you shouldn't respond to that, right? That everybody needs to
Exactly.
learn about what AI can do and where there can be problems. No, I this is great how this all kind of connects together. And maybe as one last topic before we go to our lightning round question, I know one of the things that we talked about as we were preparing for this session was this idea of the new workforce and how digital twins and AI is going to change the way our workforce kind of operates, and the standard of care and the scale that happens here that we've been talking about, how that affects things. What does that mean when you think about the new workforce and what's going to change as we go forward?
This is a question that is on everybody's mind. Is how do we educate the new workforce in the age of AI, and what kind of skills are still relevant in the age of AI, and also part of it also is what you said at the very end is responsibility. Is how do we educate and spread the responsibility? Responsibility is not only the part of the developers, it's part of the user, it's part, it everybody should, it's a shared responsibility. So there's a lot of parts. So how education has to adapt to the age of AI. I mean, there's some stuff we don't need to teach anymore, and some stuff we have to teach. We can have to always teach the fundamentals. We have to teach why we're doing what we're doing, as opposed to like the little prescriptive things that we focus on in a lot of our curricula that a machine can now do easily. So there's a lot in our curricula that has to change. In terms of we have to think of our new workforce as they are the AI generation, not us. We built it, we are advancing it, we explain it, but they are the ones who are really native, and they can take it and do stuff with it we never thought could ever be done. Think about it, when we invented the computer, or even the internet, the purpose it was invented for, the new generations took it in ways our original inventors never envisioned it. So the new this technology and this new twinned world is not for us. It's for the new workforce. It's for the new generation. So we have to educate them. Where having them, we don't have to fuss about what we learned and how we learned it. No, as long as they know the fundamentals, as long as they're responsible, as long as they have the standards of care built into them as well, I think this is how we should go about educating them. What skills are still relevant for them? I would say skills that cannot be mini tasks here and there. That anything that cannot be automated, anything that has human interaction, love, care, nursing. There's a lot of skills that we cannot replicate, and even if it's a machine doing it, we'd rather a human do it. So that's another thing. And also, as I said, the responsible part. So this is my 2-minute answer to that.
I love that. No, I think that's super a good framing on what people need to focus on. And I know, Juan, you're probably thinking the same thing, like the focus on fundamentals, right? A lot of people are asking, "Oh shoot, is this going to take my job?" Not if you understand the fundamentals, and
Yes.
not if you care and you have that standard of care and you're taking responsibility and shared responsibility, and not if you have empathy and human emotion, because that's going to be the last thing that we replicate.
Empathy is a theme that 5 years, almost 5 years now doing the podcast, I can pinpoint to so many times empathy has been a theme throughout this, and I love that it's a topic, it's an aspect that unites us in this data world. At the end of the day, like all this stuff that we do with data and technology, it's a means to an end, so other humans
Yes.
can be able to go do something, and we need to be able to understand, be empathetic about the process that they're doing and what they're trying to go do and why they're trying to go do
Yeah.
that. And that's how we know that we can be able to go serve and do things all better and so forth. And woof, okay, we got so much to wrap up now. But before we even get to our takeaways, it's our lightning round. All right, quick 4 questions. Let's kick this off. Number 1. So you mentioned that digital twins may have started kind of catching on, especially kind of like things like in AutoCAD and manufacturing, and right. Would you say that today manufacturing is at the forefront of digital twins, or is there other industries that are in the forefront of this?
I would say organizational processes a lot, and also weather forecasting. There's a lot in work there. So weather organizations are always all organizations that are investing in AI. It's because they want to twin their processes. So that's huge over there. Manufacturing, I would say, has been before the AI age. Twinning, digital twins in manufacturing has been before the AI age, but now it's enhanced and there's more communication, there's more language models on top. Yeah.
Cool.
That makes sense. All right, second lightning round question. When you first started explaining digital twinning and that it's trying to imitate that thing and it's interactive, the phrase came into my head of interactive simulation, right? Is that a good definition? Because the reason why I'm a little hesitant about it is because
Mhm.
does simulation imply that it's fake? Because obviously
Mhm.
a digital twin is more real and observed. So
Mhm.
is
Mhm.
interactive simulation a good shorthand?
You can add to it interactive simulation and testing between the physical and the digital environment. So if you add, it's not fake if you in the same sentence add the physical twin,
The
not only
physical
the
and the
digital.
digital being
So the
integrated.
interaction between the two, the back and forth, the live interaction between the two, that's how it you would fix the sense that it's fake. It's not fake.
Wow, that's
It's
awesome.
a blending between physical and digital realities.
Well, that's excellent. That's a great summary of it. Juan, over to you.
When we were talking about the processes, we talked about how this is the graph and kind of, my background in graphs and knowledge graphs. So question is, are you seeing organizations exploring more graphs and knowledge graphs as part of this of digital twins?
They no, I'm not, but they have to. And any organization that's interacting with me is starting with graphs. I think that's the only way to do it, to it's actually an easier way of modeling, and it's yeah, it's the right way. It's a guided way. I think also intelligence. I think we don't only process using neurons in our head. We also have a mental ontology or a knowledge graph in our head as well. That's if you say what makes a person very intelligent is they connect more things together. So we have a mental graph, and I think that's the way to go about it.
Yeah, the
So
relationships
I
and
am an advocate. People, organizations who interact with me, they're gonna do graphs.
love that.
Tim, final question.
All right, final question. This is actually an open-ended one, but hope you can give us sort of the quick answer here. For listeners that are interested in learning more about digital twins, in addition to obviously checking out your upcoming book called AI-Powered Digital Twins, where would you recommend they start? What's the best starting point?
They would start in why they care about that. Why do you care about it? Because you want to pivot in your career. Then, in that sense, you start with what kind of digital twins are there now, as opposed to where they are, I don't know, 10 years ago. So, always start with the state of the art and work your way backwards, as opposed to start in little details that are no more useful. So even if the state of the art is very difficult, start there, learn the language. Even if you don't understand anything, work your way backward to the details. Now, if you care about digital twins because of something in your own work, then I would start who in my community is doing something like I care for, and I'd start there and again work my way backwards to the details, to the technologies that are being used, to the modeling. Always, yeah. So I start in the opposite usually than most people start kind of small and go. I start okay. Tell me what's out there, and then let's see how it applies to us.
All right. All right. Takeaway time. Tim, we got a lot to go through. Take us away through takeaways.
I'm daunted by our
Yeah.
notes here. I'm gonna have to do my ultra best at summarizing. So we started with what is a digital twin, and you mentioned that there's levels of a digital twin, right? There's of objects like the engine of a wing or a plane, right, or a building. There's processes where you're trying to streamline, understand, document, simulate, test, and streamline a business approach, right? And then there's of humans, right? And actually, in our talk at the beginning, we actually started more from the human perspective just because we're thinking about how robots and AI can help solve problems for us. But this is the reasoning layer, and it's doing things that humans can do. And all of these are different kinds of twins, and together they combine together to create a more powerful digital twin. And so, kind of in summary, you said the definition was the virtual cloning of objects, processes, or humans. And not just a clone, but you can interact with it, you can modify
Correct.
and augment it, and it's a back and forth symphony. So it's the interaction of the physical and the digital interacting together that makes a digital twin, and also makes it valuable. And you said we've been digital twinning since the dawn of the digital age. By the way, I feel like everybody needs to start using hashtag digital twinning,
Yes, love
and
it.
like make a robot version of yourself and you're wearing the same shirt or something like that. I don't know. Figure it
I
out.
love that.
But now, as time has gone on, right, we've gone from very simple or rudimentary versions of digital twins to much more complex twins, right? And you mentioned the growing compute power, what we're able to do with AI, what we're able to do with GPUs, right? All these things are now leading up to being able to do way more with digital twins. And I mentioned an example with like Hadoop and big data, right? That was an important part of the journey too, because now we can have more data than ever and we can use more compute than ever. So we're all on this story of how do we create better and more effective and impactful and more intelligent digital twins. And you mentioned there's some cautions too, though, right? And I know probably Juan will go a little bit more into this, right? But there's vulnerabilities and harm that can come from digital twins, because now it's not just about the harm you can do to the physical environment. You're giving, harmful or bad actors superpowers by potentially allowing them to interact with the digital twin, which really can affect your business and also give them a view into your business or your process or you or whoever it is, more so than ever before. And then I'll pass it on to Juan right after I'll say that we then started talking about AI and how that connects to digital twins. And if you are, trying to digital twin a process or an object or a human, when you bring AI into it, it takes it to another level, right? Like with humans, now you can, interact with it in natural language. Like we mentioned, like the Reed, thing that he does with imitating himself. If it's a process, being able to take the documentation about that process and make it automatically clear where there's conflicts and evolve documentation and help have a dynamic process graph. And then for objects, things like being able to have faster and smarter ways to learn versus the things we'd have to do manually. Much more, but Juan, what were your big takeaways?
Okay, so we can continue. Like, how do we start? And I like how you're saying, like, don't boil the ocean, don't twin everything you have, right? You got to start with the pain points. Like, in a way, this is like stating the obvious, but again, you have to state the obvious over and over again, right? Who are the people, and what parts do you want to go automate? And this is where the human-centered approach comes in, right? Who has those pain points? Let's go ask them. What are the workflows that they're going through? Get their ideas on how to improve. And if somebody says everything's totally fine, okay, fine. Let's go find the next person who actually wants to improve their work process. And humans need to be part of this, because they're the ones who are going to know that if this automated process is actually doing it correctly, doing it accurately. Important to know that in the age of AI, it's now made easier than ever to interact with bad actors and good actors. So the attacks can happen with AI. The protection can also happen with AI. You can also do things at scale with digital twins that was not never possible before, right? And so going back to like thinking about AI-powered digital twins on the humans, on the process, on the objects, as we were just saying, like now we can do things that it was just so much more manual before. The standard of care. This is a very eye-opening for me, because when you look at it in things like in engineering, architecture, they've always been there. The fire department has a standard of care. Anything that you have to rely on that affects your operations and safety. So you went through the definition of this kind of for engineering. It's the knowledge experience for a project that meets specifications and prevents harm. The responsibility must account for additional load of things. All aspects considered. It's inspected. It's documented. Responsible parties are signed off. So how does this apply to software engineering or AI? Well, for computer science, software, AI, like this didn't used to at least feel that the stakes were as high, but they are really high right now. And kind of part of this is like, this is where governance comes in, right? This is where cybersecurity, responsible AI comes in. So it's these standards of care. And we close with the whole, what is the new workforce, right? This shared responsibility. Education has to adapt. We have to teach the fundamentals, why we're doing what we're doing, but there's a lot of things that need to change, right? We need to adapt to this new AI generation. They are the native ones, and they're going to take the stuff that we're doing to things that we never even could have thought that we could do, because it's different than this new native generation than us. Don't fuss about, I like this. Don't fuss about what we learn and how we learn. They just need to learn about the fundamentals and the standards of care built into them. But what are those skills? Are the things that can't be automated. That human interactions, love, care, responsibility, empathy. All right, how did we do?
Wow. Oh my gosh. Floyd, I mean, I think you guys should send me the summary and I'll just put it in my book right away. You just wrote a
All right,
couple
well,
sections.
it will be
You wrote the preface.
it, will- it will be out there. We got the transcripts. We'll definitely send it to you. So, all right.
I love
To wrap up, throw it back to you. 3 questions. What's your advice? Who should we invite next? And what resources do you follow?
Oh wow. My advice, if I haven't given enough in this podcast, um, do not feel overwhelmed. It might feel very overwhelming, the amount of knowledge, the amount of tools, the hype. You might feel behind. You might feel like you don't know anything. Do not just start with what you care for, what you want to do, and just start from there. Build one little brick at a time, and always ask your questions. A question, if it's in your head, ask it and get the answer, and that's how you build yourself up. And talk about what you're learning. So that's my advice. Do not get overwhelmed. It is overwhelming. You don't it's we all are in the same boat here. We were Juan and I were talking before we started the live, how we both feel like imposters. I feel like imposter. I'm a mathematician. He's a computer scientist. We were laughing about who feels more imposter. So this is just how it is. That's my advice. Who should you have next? Oh, there's a lot of amazing people out there. Have Lucian Niemeyer. He is my co-author, and he is the one who came up with the idea of standard of care. So I wanted to do AI native, digital twins, AI powered, and he's like, you have to do standard of care. And so it's his idea, and he can talk a lot about cyber digital twins, security. So he's a very good follow up to this. And what was the last question?
What resources do you follow? People,
Ah,
blogs, conferences, magazines.
oh,
I don't know.
yeah.
Newsletters.
I follow. I follow. That's a good question. I follow you. I follow. I talk. I read a lot. I read the MIT Technology Review. I read the Batch. I read a lot of business resources because I feel in the end, we are not doing these technologies just for the sake of technologies. We're doing them in service of businesses and organizations. And so I read a lot of that world and what they care for and how we can deliver for them. So I didn't understand their world from as a tech person. And then I worked myself through that. I read a lot of data engineering because that's where I felt my gap was. I know AI, I know math, I know some computer science, but I don't know the infrastructure. So I read a lot of data engineering books. I followed juries, and I learned a lot from all of you guys. I read about knowledge graphs because I do think, and computational graphs. I think these are this is what's gonna put everything together in the correct way. I think that's the right way to model. Let's start with the graphs. So these are the resources. Conferences, I go to a lot of conferences. I'm at the intersection of industry, defense, military, academia, and government. So you find me in a lot of types of conferences. I started going to cyber conferences because it's of the importance of cyber now, which I didn't know before. I started. It's been a year that you find me regularly there. So these are my resources.
Well, I this is what I love about asking this question to people, because you get this broad, right, diversity of different areas and things to
Uh,
consider. So
Everybody answers differently, and but there's some themes, right? Like for example, you mentioned some of the things that you have a lot of comfort in, and you're trying to get stronger in. But then, like also like cybersecurity, right? Like let's learn something new that I know I need to expand into, right?
Exactly.
Hala, thank you so much. This has been a fantastic conversation because I'll be honest, no BS. This whole digital twin for me has always been like, yeah, well, what is this? This is like, how much are we just
Digital
repackaging?
enigma.
We're repackaging the old stuff and new things, whatever. But we've really this really helped at least me personally. And this is one of the reasons I like doing the podcast, is because I get to be very selfish and learn. So thank you so much. And cheers. See you soon. Looking forward to our next conversation in person.